Hi, I'm Cheryl Leach. In this problem, we're given the derivative of a function, and we're going to use that derivative to find out some information about the graph of the original function. It's going to be interesting because we don't even need to know what that original function looks like. So let's take a look at our first question. I know that my derivative is 2x plus 5. I want to know when f prime of x is increasing and decreasing. Now we know that whenever we want to find out when any function is increasing or decreasing, we need to look at the derivative. My function is a derivative to begin with, so to see if it's increasing or decreasing, we need the derivative of the derivative. In other words, the second derivative. So the second derivative is simply a 2. Now we know that a function is increasing when this derivative is positive and decreasing when it's negative. My second derivative is 2. It's always positive, which means that the first derivative is increasing on the entire interval from negative infinity to positive infinity. All right, well, let's move on and see if we can get some information about the actual function f. The second question asks us, when is f, not f prime, but f, concave up and concave down? So we know we can determine concavity by looking at the second derivative of the original function. Right? Well, we've actually already calculated that in part A, and we know that the second derivative is 2. Functions are concave up when the second derivative is positive. So our function is concave up from negative infinity to positive infinity. In other words, everywhere. It's never concave down. All right, we're going to move on to the next question. We want to determine what the x values are of all the relative extrema of my original function f. Now again, be careful which function we're dealing with. If we want to find relative extrema, we want to know when the first derivative is equal to 0 or undefined. And if we look at our first derivative, that was the function that was given to us at the beginning. We can see that it's never undefined, so we don't have to worry about that. However, 2x plus 5 could equal 0. Solving for x, we see that that happens at negative 5/2. Last question. For what values of x is my original function, or does my original function have an inflection point? Remember, inflection points happen when there's a change in concavity. And we've already determined for our function f that it's always concave up. There's no change, so there will be no inflection points. And so now we've really got a lot of information about the concavity, the relative extrema, and also the inflection points of my function f, and I never knew what the equation of f was. I hope this helps. Thanks.